Let's take a look at section 4.3, which is solving quadratic equations by factoring. This is a method for solving quadratics that's a little bit more accurate than the solving by graphing that you did with the last section. As we saw with solving by graphing, it's a little time consuming, and not always does the graph cross the x-axis at integer values that we can easily determine. Therefore, we often approximate. Solving quadratics by factoring give us more exact answers. However, not everything is factorable, so it's not the most reliable method for solving quadratics. We will look at two more methods that are our go-tos. All right, so when we are solving by factoring, the most important thing is that we just remember all of our factoring rules. So let's just review a few basic factoring problems. I'll do two of them, and then you try two of them. So for number 2, we'll start with, I see here that I have a GCF, right? That's the first thing I always check for. So that GCF is 2x. I will factor out 2x, and I'm left with x squared minus 6x plus 9. From there, I look to see if I can keep factoring. That 2x is my GCF. That just stays out. And now I have a trinomial with leading coefficient of 1. So what multiplies to 9 adds to negative 6. It's x minus 3 and x minus 3, which you could leave as is, or we could write that as 2x times the quantity of x minus 3 all squared. Okay, so just our factoring. How about number 3? Well, number 3 is x to the 4th. We didn't learn any perfect fourths. However, this is a perfect square, right? The square root of x to the 4th is x squared, and the square root of 16 is 4. So this can become x minus 4 times x plus 4. It's a difference of 2 squares. Am I done? Whoops, sorry, x squared minus 4, x squared plus 4. Am I done? No. This first factor is another difference of 2 squares, so it can factor to be x minus 2, x plus 2. I cannot factor x squared plus 4 because that's a sum of 2 squares, and there is not a rule for factoring a sum of 2 squares. And so here's my factorization. Okay, you try number 1 and 4. Remember all of our ways of factoring. GCF, check for trinomial. If there's a leading coefficient, you may have to use factoring by grouping. If there's more than 4 or more terms, you need to factor by grouping. Okay, so give those two a shot. Now let's actually talk about what we're looking for. We are looking for solutions to our quadratics. As you recall, solutions can also be called roots. They can be called intercepts. They can be called zeros. And why they're called zeros is because, as you remember, the solutions are, I should be a little more specific, the solutions of a quadratic function are the x values that make the equation equal 0. Okay, so it's what are your x's when y is 0? Well, when y is 0, that's our x-intercepts. So that's why we also say intercepts. So when we're solving by factoring, the first thing we need to do is make sure that we are in general or standard form. Once we're in standard form, that should mean that our equation will be equal to 0. So we've moved everything over to one side and the equation equals 0. Then you can go ahead and factor. Remember, always GCF first. Once you're in factored form, we're going to set all of our factors equal to 0 and solve. So here's an example done out already for you. You can notice it's not equaling 0. It's not in standard form. So I first subtract 10x. And then I have it in standard form, ax squared plus bx plus c. Factor out a GCF. Then I factor that trinomial. And I'm going to set each factor and each factor that has a variable, notice, to 0. So our 2 is out front, but that doesn't equal 0. That doesn't have a variable, so I'm not going to set 2 equal to 0 because I'm looking for x. So I just set x minus 2 and x minus 3. So our solutions are 2 and 3. And we write that as a solution set. Okay? The only other way I would accept is if you had something like this. You're telling me the ordered pairs. That would be okay as well. So let's look at a couple together and then you will try them on your own. So why don't we just do number 4 together? So if I look at number 4, I need to get that in standard form. So I need to subtract 4, and I also need to add 3a. This gives me 20a squared plus 6a minus 8 equals 0. At this point, I can now factor. So there is a GCF of 2. Factor that out, and I get 10a squared plus 3a minus 4. Now I ask myself, can I continue factoring this trinomial? And it has a leading coefficient. So remember, if we're doing factoring by grouping, what multiplies to negative 40 and adds to 3a. Otherwise, feel free to do guess and check. I'll do factoring by grouping. I'm going to not forget about my 2 out front. Now I'm going to factor this trinomial. What factors to negative 40 and adds to 3a? That would be a negative 5a and a positive 8a. So I'm going to rewrite that trinomial as 4 terms. Once I have those 4 terms, I will then group the first 2 and second 2. That first grouping has a 5a in common. I take the 5a out, and I'm left with 2a minus 1. The second grouping has a 4 in common, so I take out a positive 4, and I'm left with 2a minus 1. We know we did this correct because the 2a minus 1s match. Therefore, my final factorization is, don't forget about the 2 from out front, then we have 5a plus 4 and 2a minus 1. Remember though, that's just the factorization. I'm trying to solve the equation. So now I need to take my factors with the variables and set them to 0. So I don't need to worry about the 2, but I am now going to set 5a plus 4 equal to 0 and solve. Subtract 4 divided by 5 gives me negative 4/5. The second one, 2a minus 1 equals 0. I'm going to add 1 and divide by 2. That gives me 1/2. So my zeros, or my solutions, are negative 4/5 and positive 1/2. And notice that's not an ordered pair combined. That's in set notation. Okay? So recall all your factoring rules and try numbers 1, 2, and 3. Okay, now what if I'm given the roots and solutions and I want to write an equation? We have a couple of ways to do so. Okay, so if I have 2 roots, remember to get those answers, we set a factor to 0 and solved. So I'm going to sort of undo that. In my first example here, I had the root of 2/3. How would I get 2/3? Well, if I set x minus 2/3 to 0, I would add 2/3 to both sides, so I would get x equals 2/3. Therefore, one of my factors is going to be x minus 2/3. To get a negative 5, I would have to have the factor of x plus 5. So one factor will be x minus 2/3 and one will be x plus 5. Now when I'm writing in standard form, that means I need to FOIL this out. So I FOIL out and combine my like terms. Standard form does not want fractions though, so I'm going to clear those fractions by multiplying by 3. The other way to avoid these fractions is, instead of using a fraction to begin with, think of a factor that would give 2/3. So to get 2/3, not only could I be x minus 2/3, but I could be 3x minus 2, right? When I set that to 0, I add 2 and divide by 3, and that gives me 2/3. And then the x minus 5, that one's still straightforward, of x plus 5. No fractions here, so when I multiply and combine like terms, I should be done right away instead of having to clear. So let's double check. 3x times x is 3x squared plus 15x minus 2x minus 10. Combine those like terms, 3x squared plus 13x minus 10. Voila, same thing. Okay, so you can use the fractions and clear, or think of a factor that wouldn't give you a fraction right away. So if I do one more together, we'll do number 1, and I'll leave that more challenging one for you. So to get a positive 5, I really need to have the factor of x minus 5. And to get a negative 3, I really need to have the factor of x plus 3. Because if I set those to 0, x minus 5 would give me positive 5, and x plus 3 I would subtract and get negative 3. Now we want that in standard form, so I FOIL and combine my like terms. And there's your solution. Give number 2 a shot. All right, let's take a look at one word problem. We're going to look at a bunch of word problems, but let's start with one that you're going to use quite often with quadratics, and you'll use this in calculus and physics a lot as well. So this is your position function, okay, or a height function. And what it's saying is that h of t, which represents our height, is given by negative g t squared plus what we say v naught times t plus h naught. So let's talk about what all these variables mean. The negative is always going to be there, and that's because g represents gravity, and what happens is that gravity pulls an object down. So this is going to be a parabola that's opening down because gravity is going to take an object that's in the air and pull it down. So we'll always have a negative out front. Now that g value will either be negative 16 or negative 4.9. When we're talking about feet, so if your problem is in terms of feet, we're going to use 16. So we'll have negative 16. If it's in meters, we use 4.9 for gravity. So that would be negative 4.9. You want to memorize those two numbers. Our t is simply our time in seconds. V naught is our initial. Whenever you see a little 0, we say naught, and that's always referencing the initial, right? When it's 0, so the initial, the starting. So our initial velocity is what V naught is. Again, t is time. And then h naught is our initial height. So notice we have two different h's in the equation. H naught is the height I started at, and then the function h of t is the new height I'm looking for. So in this example, Laura dove into a pool from 48 feet high. Her initial velocity was 8 feet per second. Find the time at which she enters the water. So let's start by coming up with the equation. I'll write the general equation down and we'll fill in the values we need. So because I'm talking about feet, our g value is going to be 16. So we'll have negative 16. We'll find the time. So I don't know time, so I'll leave t as is. So negative 16t squared plus v naught is our initial velocity. That initial velocity is 8 feet per second. Again, we don't know the time, so there's t. And then h naught is our initial height. And she dove into a pool from 48 feet. Now I need to fill in h of t. Do I have that? Well, if I'm looking for time, I better know that because I only want to have one variable. If I'm looking for time, what is my height? Well, the new height is when she enters the water. The height of the water is 0 feet. It's ground level, right? The water is at ground level, which is 0 feet. So that's why I put that there. Now that we have our quadratic equation, we can actually go ahead and we can solve. So what I'd like you to do is go ahead and solve this problem. It's already equaling 0, so go ahead and factor and solve. Okay? If my question had said, when would she be 4 feet in the air, then I would set my equation equal to 4, and so forth. Before we move on, let's just understand why this is a quadratic function, right? So if Laura is on some diving board way up high, and there's water down below, remember when you're on a diving board, you take a jump, and then you fall into the water. So notice this shape, right? The shape I just created is a upside down U, which makes sense, right? Our parabola opening down because I have a negative out front. Again, finish part A. Part B says, what was the maximum? What's another word for maximum? Can anybody think of that? I'm hoping some of you did. And another word for max is the vertex, right? Our vertex represents a maximum or a minimum. In this problem, we know we have a max because that graph is opening down. So this question is simply asking us, what is the vertex? So let's do that. How do I find a vertex? Well, if I'm not in vertex form and I'm in standard form, I start by finding our axis of symmetry. X equals negative b over 2a. So I take my equation and I plug in those values. X will equal negative 8 all over 2 times negative 16. If I simplify that, that gives me negative 8 over negative 32, which is 1/4. That is not my answer, right? We need to find the entire vertex. So when I plug that into my equation, okay, so I plug that back in, we have that h of t, that new height at 1/4 will equal negative 16 times 1/4 all squared plus 8 times 1/4 plus 48. And when we calculate that, I'll let you do that calculation. So negative 16 times 1/4 all squared plus 8 times 1/4 plus 48 gives me a height of 49. So that's telling me my vertex is 1/4, 49. So what that's saying, and I'll use a different color because I can't scroll any further, is that the max height is 49 feet, and that was after 1/4 of a second. Now, that makes pretty good sense, right? When we're diving into the pool, we usually try to aim right in towards the pool. So I'm not going to jump up super crazy high to then dive into the pool. So it is increasing a little bit because we hop off that board, and then the rest of my journey is to fall down into the water. Okay, so finish up those other problems and you may submit your work. Have a great rest of your day.